For thousands of years, the accumulation of human knowledge was bound by the physical limits of the human hand. Before the middle of the 15th century, every book, every manifesto, every religious text, and every philosophical treatise had to be painstakingly copied word by word, letter by letter. In Europe, this grueling work fell largely to monks in scriptoriums, hunched over parchment for hours on end, guided only by the flickering light of candles. The process was agonizingly slow. A single copy of the Bible could take a scribe an entire year to produce. Because of the immense labor involved, books were incredibly rare and astronomically expensive. They were luxury items, often chained to library desks to prevent theft, accessible only to the clergy and the extreme elite. The vast majority of the population lived and died without ever holding a book or knowing how to read. Information traveled at the speed of a horse or a sailing ship, and ideas were easily lost, corrupted by copying errors, or confined to isolated geographic pockets. Yet, the desire to reproduce text was not new, and the earliest solutions emerged far to the east. Centuries before the printing press transformed Europe, innovators in Asia were already making monumental strides. By the 2nd century AD, paper had been invented in China, providing a lightweight, cheap alternative to parchment and vellum. By the 8th century AD, Chinese artisans developed woodblock printing. They would carve entire pages of text and images into a single block of wood, ink it, and press it onto paper. This technique allowed for the mass production of texts such as the Diamond Sutra, the world's oldest known dated printed book, produced in 868 AD. However, carving a new wooden block for every single page was a colossal undertaking. And if an artisan made a single mistake, the entire block was ruined. The next logical step was to break the text down into its individual components. Around 1040 AD, a Chinese alchemist named Bi Sheng invented the world's first movable type. He baked individual Chinese characters out of clay and porcelain, which could be arranged on an iron board to form a page, printed, and then rearranged for the next. 2 centuries later, Wang Zun improved this system using more durable wooden type. Then, in 1377 AD, artisans in Korea achieved another breakthrough by casting movable type in bronze to print the Jikji, a collection of Buddhist teachings. However, the sheer complexity of East Asian writing systems, which contained thousands of unique characters, meant that movable type was incredibly cumbersome to organize and use. As a result, woodblock printing remained the dominant method in Asia for centuries. Meanwhile, 15th century Europe was undergoing a profound transformation. The devastation of the Black Death in the previous century had ironically led to better living standards and a rising middle class. Urban centers were growing, trade networks were expanding, and universities were sprouting up across the continent. There was an unprecedented thirst for knowledge, administrative records, and literature, but the scribes simply could not keep up with the soaring demand. The stage was set for an industrial solution to an intellectual bottleneck. The solution would not come from a scholar or a monk, but from a pragmatic craftsman trained in the manipulation of metal. Johannes Gutenberg was born around 1400 AD in the German city of Mainz. Growing up in a patrician family with ties to the local mint, Gutenberg learned the trades of goldsmithing and gem cutting. He became intimately familiar with metallurgy, casting, and precision mechanics. Political upheaval forced him to relocate to Strasbourg in the 1430s, where he engaged in various entrepreneurial ventures, including manufacturing mirrors for pilgrims. But behind closed doors, Gutenberg was working on a secret project, one that consumed his time and drained his finances. He referred to it vaguely in legal documents as the work of the books or the enterprise and art. Gutenberg recognized that the Latin alphabet, unlike the vast character sets of Asian languages, consisted of only a few dozen letters and punctuation marks. If he could mass-produce these individual characters uniformly, they could be endlessly combined, printed, and reused. But the technical hurdles were immense. Wooden type was not durable enough to withstand the pressure of repeated printing, and existing metal casting techniques could not produce the exact dimensions required for letters to line up perfectly on a page. Gutenberg's genius lay not in a single radical invention, but in the brilliant synthesis of several disparate technologies, heavily modified to solve the problem of mass printing. His most crucial innovation was the adjustable hand mold. To create a letter, Gutenberg first carved a steel punch with a raised backward image of the character. He hammered this punch into a softer piece of copper, creating an impression called a matrix. This matrix was then inserted into the bottom of his hand mold. Gutenberg then poured molten metal into the mold to cast the type. To ensure the metal cooled quickly and shrank just enough to be removed from the mold without warping, he developed a unique alloy of lead, tin, and antimony, a formula so perfect that it remained the standard for printing type for over 500 years. This hand mold allowed a skilled worker to cast thousands of identical, perfectly squared letters in a single day. But letters alone were not enough. Gutenberg needed a way to press them onto paper evenly. For this, he looked to the agricultural technology of his time, specifically the heavy wooden screw presses used to crush grapes for wine or olives for oil. He adapted this design to create the printing press, outfitting it with a flat, lower surface where the composed type was locked into an iron frame, and an upper plate, called the platen, which lowered to apply even massive pressure. Furthermore, traditional water-based scribal inks would simply run off the metal type. Gutenberg had to invent an entirely new oil-based ink containing soot and linseed oil, which adhered precisely to the metal and transferred cleanly and permanently to the paper. By 1450 AD, Gutenberg had returned to Mainz and set up a functional printing shop. He borrowed a massive sum of 800 guilders from a wealthy financier named Johann Fust to fund his operations. To demonstrate the unparalleled power and beauty of his machine, Gutenberg chose the most culturally significant text of his era. Compiling the sacred scriptures, originally chronicled in Palestine, modern-day Israel, and later translated into the Latin Vulgate Bible. He aimed to produce a printed book that rivaled the finest hand-illuminated manuscripts in quality, while drastically undercutting them in price. The production was a monumental logistical feat. It required composing thousands of pages, casting over 100,000 individual pieces of type, and sourcing vast quantities of high-quality paper and vellum. Around 1455 AD, the Gutenberg Bible, also known as the 42-line Bible, was complete. It was a masterpiece of typography, boasting crisp, black text arranged in 2 perfect columns per page. When copies of the Bible were exhibited at the Frankfurt Book Fair, the reaction was sheer astonishment. A future pope, Aeneas Silvio Piccolomini, wrote a letter marveling at the Bibles, noting that the lettering was so clean and legible that one could read it without glasses, and that the entire edition had sold out before it was even finished. The printing press had achieved the impossible. It had mechanized the creation of the written word without sacrificing its aesthetic majesty. Tragically, Gutenberg's business acumen did not match his inventive genius. By the time the Bibles were being sold, he had defaulted on his massive loans. Fust sued him, winning not only the return of the money, but also control of the printing equipment and the lucrative Bible inventory. Fust went into partnership with Peter Schurfer, Gutenberg's former apprentice, and the two went on to reap the immense financial rewards of the invention. Gutenberg was effectively marginalized from the industry he had created. He lived out his remaining years in relative obscurity, receiving a small pension from the Archbishop of Mainz before dying in 1468 AD. He never put his name on a single printed document. Despite Gutenberg's personal downfall, his invention could not be contained. The secret of movable type broke out of Mainz and spread like wildfire along the trade routes of Europe. Printers set up shops in Venice, Paris, London, and beyond. In the 50 years following the invention of the press, a period known as the Incunabula, an estimated 8 to 20 million books were printed in Europe, representing more books than had been produced by all the scribes in Europe during the previous millennium. By the dawn of the 16th century AD, books were no longer the exclusive domain of the ultra-rich. The printing press had slashed the cost of books by orders of magnitude, making them affordable to the expanding middle classes. The societal impact of this information explosion was absolute and irreversible. The printing press became the catalyst for the major intellectual movements that shaped the modern world. When a relatively unknown monk named Martin Luther wrote his 95 Theses, criticizing the Catholic Church in 1517 AD, his ideas did not languish in obscurity. Thanks to the printing press, his words were rapidly reproduced and distributed across Germany and Europe within weeks. The press fueled the Protestant Reformation, allowing individuals to read religious texts in their own languages and interpret theology for themselves, breaking the Church's absolute monopoly on spiritual authority. Similarly, the printing press laid the foundation for the scientific revolution. Before the press, Scientists and natural philosophers worked in isolation, and their findings were frequently lost or degraded by scribal errors over time. With standardized printing, exact diagrams, astronomical tables, and botanical illustrations could be perfectly replicated. Scholars could easily publish their theories, review the work of their peers across the continent, and build upon a reliable foundation of shared knowledge. The works of Copernicus, Galileo, and Newton were propelled into the public consciousness by the gears of the printing press, accelerating the pace of human discovery to breakneck speeds. Beyond religion and science, the printing press standardized regional dialects into unified national languages, laying the groundwork for modern nation-states. It gave birth to journalism, broadsheets, and pamphlets, creating a public sphere where political discourse could thrive outside the control of monarchs. It fostered widespread literacy, fundamentally altering the way human beings process information and think about their place in the universe. In automating the spread of knowledge, Johannes Gutenberg did not merely invent a machine, he built the primary engine of modern civilization, democratizing the power of the written word and ensuring that humanity's collective memory would never again be held hostage by the fragile hands of a few.